So our next session and our final one before lunch is one of this series of amazing women sessions. So as we know, we've got many amazing women. There are 3 who are going to be joining us for a discussion, a very short, in fact, an impossibly short discussion, just 15 minutes. We're going to have a chance to explore what they're doing and how it's contributing to our theme. Now, this one is a special one because we're going to be introducing some technology. And you know, whenever you've got technology in a session, you kind of keep your fingers crossed that everything is going to work out. As sadly, our speaker is ill. And so she's going to be speaking to us from South Africa. And we won't have video, so we won't do that to her. We'll let her be an audio interview. However, our interviewer is here, and I'd like to invite Claire Doole to join us. She is going to be doing the interviews for all 3 of these amazing women features. She's the founder and CEO of Claire Doole Communications, and she's going to be drawing on her extensive background as a BBC correspondent and from different places, public relations professional. She's been the spokeswoman for UNHCR, the International Federation of Red Cross, and she was the head of media for WWF. So, Claire, I'd like to give you the floor, please.
Jill Farrant is an amazing woman. She is Professor of Molecular and Cell Biology at the University of Cape Town in South Africa. She is also the world's leading expert in resurrection plants. These are plants which appear dead, but suddenly, miraculously, when watered, come alive. You don't believe me. I can see the skepticism on your faces. But if the technology works, we have a video. So please play the video. Jill, this is Mauritius calling Cape Town. Can you hear us?
I can, loud and clear.
Fantastic. A lot of applause, a lot of smiles, and of course, the first question is, how on earth do these plants do that?
$1 million question, Claire. With a lot of complex mechanisms, but I think the big important one that's come to light of recently is that they haven't got anything different from most of our crops out there. They just use their genes somewhat differently.
And I understand that your first encounter with one of these plants was at a very young age.
9 years old. I don't know if you can see the diary from where I'm holding it, but yeah, I grew up on a farm and noted this in my 9-year-old diary because it was something very pertinent to a farmer's daughter, something that came alive after rain. And I didn't immediately work on them when I did my PhD, but I worked on a seed-related phenomenon which came back to the common mechanism that I'm about to tell you about later.
And so your father, the farmer, did he believe you when you wrote in your diary about these resurrection plants?
Hell no. You know, a farmer says something doesn't go green overnight. And it wasn't a type of plant you'd notice in the field where his cattle were roaming, for example. So no, he didn't believe me, and I put my diary away and didn't think about it for a good 30 more years, really.
So tell us, how many of these species are like this?
There are only 135 higher plant species, angiosperm species, in the world that can do this. So it's a very rare phenomenon, and the reason why these plants look dead is because they have lost 95% of their water. That's a phenomenon that nothing much on this planet except a resurrection plant, and interestingly, seeds. Most plants produce seeds that can lose all that water. And we store our seeds for germplasm conservation because simply we keep them dry we store them cold, and you can store them for millions of years. So it's a very rare phenomenon and not one that agriculture has thought about to date.
But you have put it on the map, and you must have had a eureka moment during those many, many years of looking at these seeds under the microscope.
Yes, several eureka moments, but I think the biggest one, Claire, was when I finally was able to show, along with collaborators, that in fact what resurrection plants are doing are turning on genes that seeds use when they become desiccation tolerant. Now the implication of that is that any plant that produces a dry seed has the genes, but they never switch them on in their roots and leaves. That keep them off in those tissues. Resurrection plants don't. They've co-opted or retasked those seed genes to be able to switch on in response to drought. And therefore, they just mimic a seed. They go into a quiescent, dormant place until water arrives. And it can be years, Claire, that they can actually lie in that dry, dormant state.
Do you yet know how many years?
It's difficult to keep a student along to try and prove how alive they are after 3 years. But so far, I don't know if you can see, the branches of this species, up to 5 years without water, I can put it in. I can guarantee these ones are about 2 years old now. I can put them into water and I can guarantee that they will green up.
So basically, to begin with, what you were doing was genetically modifying the crops. You were trying to put the genes from the resurrection plants into some staple food crops.
Yes, it's a kind of a sideline that I've been doing. My major research goal was to get a comprehensive, fundamental understanding of what I need to do, rather than play around with GMOs along the way. And along the way, when we found promising things, we have put them into crops in attempt to see if it would improve the tolerance. Yes, they do. Nothing's gone to market. But for me, the bigger and more acceptable, maybe the best approach would be the one we would like to start trying soon, which is to actually switch on the genes that are already present in crops. So we don't add anything strange into the crop. We literally are able to modify how they respond to the genes.
I mean, it's one of those stupid questions from a former journalist, but how long do you think that that's going to take?
No, it's a very bright question, I must tell you. It'll take as long as, once I have sufficient funding, I believe 5 years. But getting the funding for end-stage research is exceptionally difficult. It's risky, it's expensive, and so I go around talking so that I could hopefully get some at some point.
So yes, you've got the message loud and clear, please, funding, and you've got her email contacts in the booklet. But what you're hoping then is that you're going to get some drought-tolerant crops, which will help some of the farmers here in Africa.
Absolutely. I think all living organisms require water, and a loss of a small amount of water results in death. The thing about these crops is that they won't die, never mind how much water they lose. When the rain comes, they will start growing from the very point where they stopped growing. So the farmer in South Africa that is a subsistence farmer, weather dependent, because most of our agriculture is rain-fed, will not lose their crop. But they might not get a fantastic crop, but they will certainly get a crop.
And have you started to test this with certain farmers?
Not yet. Wanting to get, obviously when you're going into a science like this, it has to be exceptionally well tested before you put it into the field. And so, no, we are doing all the correct steps along the way. But we certainly know that there are a lot of people who would be very interested in our research once it comes out. My idea is it must not cost anyone much. This is really just to help get through a period of drought, which is going to predictably get worse and worse with climate change.
And I understand that these amazing plants, they have medicinal applications too. So can you tell us about those?
Yeah, they do. And I think any plant that has to evade any severe stress will have chemicals in them to help protect themselves against these stresses. So if you can see, here is a tea that's just been released onto the market. I don't know if you could read it, but this is a recent tea. It's been traditionally used for thousands and thousands of years. It treats stomach ulcers. You can smoke it. It opens your chest. And Giorgio Armani have used it for a cosmetic because it's a very good antioxidant and skin protector.
I should just explain, Jill, that actually we can hear you loud and clear, but we can't see you. So that's good that you're painting this picture of this tea and the Giorgio Armani beauty creams.
But you can't see them, sorry.
Now, yes, there we are. There's a segue now into beauty with the L'Oreal UNESCO Women in Science Award. Now, you won this award, and it's an award for resolving major global challenges. And I'd just like to know, this research, do you actually hope that it is going to lead to food security? We've just been hearing about SDGs, the jargon for Sustainable Development Goals. They're about food security and combating hunger. And are you hoping that eventually that your research will lead to food security?
Absolutely. In fact, I'm going to say, for my lifetime, before I die, yes, I will be able to produce something that I believe that can help in the future. One of many solutions, because extreme drought is going to be one thing we're going to have to face. On the other extreme, it's going to be extreme wet. So countries like Mauritius might have a very different problem to face than we do. But yeah, I think in some small kind of way, my research will, and the research of my students will contribute in the future.
You mentioned the research of your students, and of course this was, a gender-specific award, and I'm just wondering whether you see that awards which are gender-specific can be a double-edged sword in any way.
They can be. I mean, on the positive side, this has done amazing things for me. People have recognized who I am. I'm more likely to get funding and things like that. On the other hand, I tend to be a woman, and I'm sure many women are like me, in that we can't say no, and we continue to push ourselves to a limit where we crash and burn, which is kind of what happened to me, I think, before I came, now.
Yeah, you need a holiday in Mauritius. I read in your bio that this is a woman who hasn't taken a holiday for 8 years. Can you just explain some of the science that your students are doing, because of course they're the next generation at the University of Cape Town?
Yeah, clearly, I have a huge program, and each one of them involved, obviously, in a small aspect of the program. But one of the things that we suffer in Africa, and I think will increasingly do so, is that we can't keep up with the technology explosion in Europe and America. And so what I'm doing is sending each of my students overseas to a lab, and we've got many universities collaborating now, where they learn a technology, they bring it back, teach their students, and so forth. So we're trying to keep cutting edge by doing it slightly differently, but it's been an amazing journey.
Well, Jill, you're an amazing woman. You're not only an amazing scientist, but an amazing communicator by Skype. And I know that you're up for an award from the National Science and Technology Forum. It's got a very long name, this award, in crop science and food security and communication for outreach and creating awareness. So good luck. I understand that you'll find out in a few days' time whether you've won that award.
Yes, indeed.
And if the room would like to know what Jill Farrant looks like, she's a pretty amazing rock chick. She has a certain style. It was Jill who put the rock music onto that video. And if you go to a TED Talk, which was shown at TED Global in Geneva last December, you will also see what Jill looks like. Jill, thank you so much for joining us.
Wonderful talking to you, Claire. Good luck with the rest of the forum.
And please take some rest and book a holiday to Mauritius.
Thank you so much. Bye.